what we're going to be looking at today is we're going to finally take our gloves off, and the stuff we've been doing for the last two chapters about quadratic functions and about factoring, etc., we're going to bring all that together so that we can solve quadratics. So today's lesson is going to be solving quadratic equations using graphs. So by way of introduction, what we did was evaluate the function with each of these values of x, and you can pause the video and see what we get. But negative 2 goes in for x here, negative 2 goes in for x there, and when we evaluate, we get 0. 2 gives me 20, negative 3 also gives me 0. Quadratic equations and solutions. So first off, let's define a few things and then give you some categories by which to evaluate quadratic equations. So a quadratic equation. A quadratic equation is any equation that can be written as ax squared plus bx plus c equal to 0. So standard form, but everything equals 0. Notice that this is an equation, not a function. A function would have a y here, and this equation doesn't. Exactly one variable, exactly one variable. And where a cannot be 0. Because if a were 0, this would be a linear. If a were 0, it would be linear. A solution to the equation is a number that satisfies the equation. That's the word we use, satisfies the equation. So it's a number that you plug in, and then it works. In a rare instance where math is confusing, we actually have 4 different ways of saying solve. So I put in quotes answers. So these are the names for the answers of a quadratic equation. Okay, the first thing we say is it's called a solution or solutions of equation. The solutions of the equation. So x equals 2 or x equals negative 3, something like that. However, we can also think about it in other words. Another word besides solutions, we often will say the roots of the function. Roots of the function, no s. Just to confuse you, we have more. Another one is called the zeros. And zeros can be spelled with or without an e. Zeros of the function. And lastly, the y-intercepts of the graph of the function. So the things to pay attention to is solutions, roots, zeros, and y-intercepts. Those are the 4 different, and they're pretty much synonymous, meaning they mean the same thing. That if I'm solving the equation, that's the same as finding the y-intercept of the graph. Solving an equation is the same as finding the y-intercept. And that's going to be key today, because we're going to be solving equations by graphing it and seeing where they cross the y-axis, where the graph crosses the parabola. So first off, I want to give you some background context to where we get our solutions and how many we get. So I'm just going to make these graphs up, but since they're all parabolas, they're going to be quadratic and they're going to be parabolas. Notice you could have a parabola that does this, like this. And we say that this has 2 real solutions. Why? Because one there and one there. Because it has 2 y-intercepts. My error being, not y-intercepts, but x-intercepts. Did I write y over there? Oh, fundamentally wrong. That should be x-intercepts. Punch me in the neck. Completely wrong. Okay. X-intercepts. So when we have one real solution, and it doesn't really matter where your parabola faces, so this one's going to open up. But notice that it's just resting on, so we have one x-intercept. Because we have one x-intercept, we have one real solution. And now it doesn't matter where this parabola is, but the important part is that it never crosses the x-axis. So for example, this right here never crosses the x-axis. It eventually crosses the y-axis down below. So that right there is 0 real solutions because it has 0 x-intercepts. Just to give a watch out for things, a warning here, if I drew this and said, oh, look, Swenson, it never crosses. Look, the parabola doesn't cross. And the answer is, yes, it does. We just don't see it cross. See, it crosses right here if we keep extending it. And this one will cross off-grid. So we have to follow the arrows and keep going. In this case, the arrows go down forever and will never go up further. So please take a moment and discuss with your neighbor, how many roots do each of the following appear to have? Go ahead and put the dots and say how many, 1, 2, or 3. Good, so for this first one right here, and I do apologize, there's only 2 options, 0, 1, or 2. So this is called 2 real solutions. Notice I'm using the word real in there. It's kind of important. Also 2 on this one here, and it looks to be about in those 2 locations, 2 real solutions. And the last one. This one has 0 real solutions. It's very important in this case that we have 0 real solutions because later you're going to find out something called imaginary numbers. And these ones do have answers that are off in a different way. Okay, now that we've identified the number of solutions on a graph, what we want to be able to do is to estimate those solutions and then check. So for these problems here, we're going to estimate. We estimate as close as we can, and if it's a decimal, we estimate the decimal. But fortunately for us, these ones aren't going to be decimals. They look like they're in whole number increments here. Unfortunately, there's no scale on this, so let's just toss a scale down real quick because we're counting by ones, so it seems in this one. All right, we're going to estimate the solutions, and then we're going to check them to see if they work. Okay, so it seems that the x value here is 2, and the x value here is 5. So those seem to be my 2 solutions. So I'm going to check those over here. X is 2 versus x is 5. So we know if it works, we know if they are solutions, if they, when you plug in a 2 here and here, I end up getting a 0. So let's test that. So I put the opposite, put parentheses around the x, which is a 2. Notice don't put the negative. It's always wise to have the parentheses when you substitute. Plus 7 times 2 minus 10 equals, with a question mark, because I don't know if that's true yet, 0. So we can check this by calculator, or if I were just going by hand, I'll show you what happens here. I get the opposite of 4 plus 14 minus 10 equals 0. All of that simplifies to 0 equals 0, and we're done. If you had put this entire part right here into your calculator, then you would just get a 0, and you can confirm that. Now we're going to do the exact same thing, but this time with a 5 to check this by hand. And no matter what, if you're asked to check it, you should always start off with the substituting the equation like so, squared plus 7 times 5 minus 10 equals 0. This ends up being negative 25 plus 35 minus 10 equals 0. 0 equals 0, and we have a check. All right, take a moment, do the try it. And now we can check our answer here. Now the last thing we're going to do is the whole thing. We're going to do everything. We're going to start with an equation, and we're going to use our calculators to go. So the calculators I'll post as a separate video than this one here because I'm going to record it off the computer. But here are the steps that we're going to do. And we can use Desmos, which can be simply done here, or we can do so on our TIs, which I'll show you in just a second here. So first off, we're going to write the equation. Write the equation as a function. As a function in standard form. actually doesn't really matter what form it is as long as everything's on one side, but standard form's a great place to do. Then you graph the function. We're going to estimate the x-intercepts, and I'm going to put a parentheses s just in case. We don't know if there's 1, 2, or 0. And then we're going to check our solutions. Now I'm going to do example 2 almost entirely with the calculator. All right, so let's see how we graph this using Desmos, or solve by graphing. So let's pull this up here. And first thing we're going to do is enter in the function, which, there it is, x squared minus 6x plus 2. Now on Desmos, it's so easy. All we have to do is tap the solutions. There it is. Boom, there's a solution. So x is 0.354, and this one is, the x is 5.646. That's it. We're done. There's nothing more to do. For Desmos, it's very easy. So if we practice another one here, let's enter some other information in. Now let's look at the second one there. All we have to do is enter that information. Now all we have to do is tap there, and those are my solutions. That's it. Oh, you got it. It's done. It's quick. It's straightforward. So all we get here is that x is 0.293 and x is 1.707. And those are my solutions to this equation equal to 0. I'll provide a link below in order for you to solve this using a TI. Thank you very much. Have a good day.